Alright guys, welcome my fellow Chemelite. Today I'm going to be teaching us how to balance a redox reaction. Okay, first of all, chill. We have to take it step by step to know, to get the info clearly. Most of you might need to watch the video twice for you to get the concept. But if you pay attention closely, definitely you'll be able to answer redox reactions without even playing this video twice. Okay, so now let's go. Alright, these are all on basis of, first of all, you have to know basics on redox reaction before you can balance a redox reaction. But by the way, I'm actually going to be teaching the basics a little bit before we balance the redox. It's actually part of it, so there's no need to, if you don't know how to find the oxidation number, I will still do it here, so just follow. Okay, first of all, before we balance redox reaction, let's know the oxidation number of the compounds. Okay, first of all, we'll look for the oxidation number of ion in this compound. So now, ion is the unknown here. So if ion is the unknown, we know oxygen, because oxygen is a constant. -2 is the oxidation number of oxygen. So now we say -2 in brackets. This 3 here is affecting this -2. Okay, so is equals to 0. So -2 times 3 will give us what? 6. So Fe2 minus 6 equals to what? 0. If we move this -6 to the other side of the equation, it will give us +6. Fe2 equal to +6. Now we divide both sides by 2. We divide both sides by 2. 2 here, 2 here, 1. So 2 go here, 1, 2 go here, 3. So now Fe is now what? Fe is equals to +3. So the oxidation number of ion in this compound is +3. Now we move on to CO. So now CO, well, we know the oxidation number of oxygen to be -2. -2 equal to 0. If this -2 move to the other side of the equation, it will be +2. So carbon in CO, that is carbon monoxide, is +2. Ion here originally is +2. Alright, so we're moving on. CO2. How do we find it? We say CO -2 bracket 2 is equals to 0. So now -2 times 2 is equals to -4. C -4 is equals to 0. If this -4 move to the other side of the equation, it will give us C equals to +4. So the oxidation number of carbon in carbon dioxide is +4. Alright, we've solved for the oxidation number of each and every compound in this redox reaction. Now let's separate the reduction side from the oxidation side. Okay, I will have to clean this out so that we sort down. Alright. Okay, from the look of things, now an increase in the oxidation number is what? Oxidation reaction. And a decrease in oxidation number is what? Reduction reaction. So now from this, what can we deduce? We can deduce that ion reduces in oxidation number, which means this is the reduction reaction. Let's write down the reduction reaction. Fe2O3 plus 3. Fe2 plus. This is the reduction reaction. So now let's write out the oxidation reaction. Obviously this oxidation reaction, because there's an increase in oxidation number. So let's write it out. CO plus 2 will give us CO plus 4. CO2 plus 4, sorry. Alright, now from the look of things, for us to be able to balance this equation, we will make sure that every atom in the product side, reactant side, is also the atom in the product side. Alright, we have to make sure that every atom in the reactant side is also the same atom in the product side. Do we get it? Alright, now from the look of things, we can see that oxygen is missing in the product side. So now, what do we do to be able to put this oxygen? We cannot just vanish oxygen into the side. What do we do? If we put a water molecule in this product side, or the reduction side of the reaction, we put water molecule here, 3 mole of water molecule here. What will happen? There will not be hydrogen here, and there is no hydrogen here. So what do we now do? We have to also put hydrogen ion. But first of all, let's impute what? The water molecule. So Fe2 3+ is equals to Fe plus 2. Now we now add 3 molecules of water. I think we should demarcate here. Alright. So now, from here, what do we now do? We now see that hydrogen is here, but hydrogen is not here. So what do? We add an hydrogen ion to this side of the equation. Now we now add it. Fe2 plus, how many hydrogen ion do we need? We will find out that this hydrogen here is how many? 2 times 3 will give us 6 hydrogen atoms. So we have to put 6 hydrogen atoms here. Okay, now let's add it. We have to add 6 hydrogen ion. Alright, 6 hydrogen ion. Okay, now let's look. From the look of things, all atoms are now balanced, but there is something missing here. The oxidation number is not balanced. We will find out that we have how many oxidation number here? We have +2 plus this 6 here will give us 9 oxidation number, but we only have 2 oxidation number in the product side. So now what do? We have to put an electron charge. We have to put an electron charge to this side to reduce the oxidation number. So like, how many electrons do we need to make here balance with this side? If we have 9 oxidation number here, and we have 2 oxidation number here, what do? Because we don't assign oxidation number to the water molecule. We can only assign it to this guy here, hydrogen ion, but water molecule no, so we don't count it. So alright, from here we can deduce that we need 7 electrons. So now let's remove these guys. So now I have to add the 7 electrons. So it plus, okay, plus 3 plus 6 hydrogen ion. We'll now add 7 electrons, because 7 minus 9 will give us what? 2. So now from the look of things, now the atoms are balanced, the oxidation numbers are balanced. Okay, now since the oxidation numbers are balanced here, let's move over to the oxidation reaction side. Okay, what do? We add a water molecule to this side, because why? Because the number of atoms of oxygen here is not equal to the number of atoms of oxygen here. So now let's add water molecule. CO2 plus how many water molecule do we need to balance this side? We just need 1 water molecule to give us CO2. Okay, now from the look of things, hydrogen is not here. 2 hydrogen atoms is here, but we don't have any hydrogen atom in the product side of the oxidation reaction side. So now let's add our hydrogen ion to this side. So CO2 plus with our molten molecule will give us what? CO2 plus 4. We need how many? 2 hydrogen ion. Alright. Now from the look of things, this side is now balanced based on what? The atoms, the number of atoms is balanced, but the number of oxidation numbers are not yet still balanced. We have to do justice to that. So okay, alright. So now what do we do to balance this? We have how many oxidation number here? Only 2. Why? Because we don't count this water molecule. But looking at this side, we find out that the oxidation number here is plus 4. How many oxidation number we have here? These 2 now multiply this 1 here is what? 2 plus. So what do we have? We have 6 plus here and we have 2 plus here. So what do? We have to add an electron charge to this side. How many electron charge do we have? Do we need to add to this side to make this side to be 2? We have to add how many? 4 electron charge to the 6 oxidation number. So now let's add it. Plus what? How many? We say we need how many? 4 electron charge. Alright. From the look of things now, everything is balanced. But what do we do? For us to be able to merge this reduction side and the oxidation side together, we have to also balance what? The electron charge we put. And for us to put the electron charge to be the same, we have to use this 4 here, the number of mole here, and the number of mole here, cross it. We have to use 4 here to multiply this side, and we use this 7 here to multiply this side. So alright, if we add the 4 from this side to this reaction, so now 4 multiply this will give us 4 molecule of this iron oxide. So now 4 times 6 will give us what? 24 hydrogen ion plus what? 4 times 7 will give us 28 electron charge. Now 4 times this guy will give us 4 molecule of iron 2 plus 4 times 3 will give us what? 12 water molecule. Okay, here is now balanced based on the electron charge. Let's do the same to this side. If we add 7 to this reaction, if we times this reaction by 7, we will now have 7 molecule of CO, carbon monoxide, plus 7 molecule of H2O to give us 7 CO2 plus 4 plus this. Now 7 times this will give us what? 14 hydrogen ion. 7 times 4 will now give us 28 electron charge. Alright, now what do we do next? We have to cancel out. Okay, we have to cancel out. So first of all, let's remove the electron charge. If we cancel out the electron charge, what next is remaining? Let's add everything up. So let's add everything. Let's add up the reduction side with the oxidation side. Alright, so now let's add up. Don't get confused. So let's add up 4 molecule of iron oxide plus what? We add 7 molecule of CO plus 2 plus what? 24 hydrogen ion plus What do we add? 7 molecule of H2O. Now here is complete. The reactant side is complete. Let's add what? 4 molecule of iron 2 plus what do we have here? We have 7 molecule of CO2 plus 4. Now what else do we have here? Plus H2O plus what? 14 hydrogen ion. Okay, now we've added the whole reaction. What do we now do? We have to cancel out. So now what and what is common here? If we cancel out this hydrogen ion, 14 go here 1, 14 go into this place, we have 10 left. After we've gotten 10 left, what next do we cancel out? We have to cancel what again? The water molecule. If 7 go here 1, if 7 go here, what is left? 5 is left. So now after we've cancelled out, let's rewrite the equation now. I will now have to clean this side and rewrite this equation. So please, if you've not written anything, write it down and let me clean it up. Alright, we're done cleaning. So now let's impute this back. We have 4 molecule of iron oxide plus 3. Always write the charge. So plus 10 hydrogen ion. Okay, we've cancelled this out, so I'm not writing it. To give us what? 4 molecule of iron 2 plus what? 7 molecule of CO2 plus 4 to give us what? 5 molecule of H2O. Alright, we are done with the balancing. Okay, now from the look of things, we have balanced the atoms, we have balanced the charges and everything. So now from here, for us to check that if this balancing of the redox reaction is complete, what do? We have to now count the charges here and count the charges here to know if truly we've balanced this equation. Alright, so now let's count together. This charge here plus 3 times this 4 moles will now have what? We have 12. 12 now plus what? We have charge of plus 2 times this 7 moles here will have 14 plus what? 10 here. So now let's go on to give us what? This 2, the 2 charge, that is the oxidation number multiplied by 4 will get 8 plus what? 7 times 4 will have 28 plus, no, we don't count the water molecule. So let's go on. This plus this, we have 36. We have 36 to give us what? 28 plus 8, we have 36. Okay, now we have checked it and it's correct. So we have balanced this equation correctly. Okay, now let's try another question to make sure we really understood this balancing of a redox reaction. Okay guys, the method I showed you in solving redox reaction, if you know you are in a dire condition whereby you need to be fast, you don't have time, please don't take those steps I took. It will waste time. If you are writing something like WAEC or JCA perhaps that you need to show them the process and everything, that is where you have to take this process down. to show them your workings. But if you are not writing WAEC, you are writing something like JAMB, the thing you need is just speed and accuracy. Go through, the last process I took, how I was able to like count the ions after balancing everything. I just counted the ions multiply them by the number of moles. That's what you just do, because since JAMB you will have 4 options. Just count the ions for the 4 options. The one that is balanced, the one that has the same ion in the product side and the reactant side are the same, that's your answer. So you don't have to solve too many things. But if for knowledge sake, please learn the process, so that in case of you come across it in exams where you have to show workings, you deliver the work. Okay, thank you for watching this video. Love you guys. You do the process I showed you. But if you are not going to write, if you are writing something like JAMB, what you just do is that do the last step I did. Are you okay? You're not doing something. You just come.
How many minutes? It's not much now.
But now I should have just attended to you now.
Look,
I don't have.
It's not about you attending to